Imagine building an entire city where nothing should exist. No rivers, no mountains, no natural resources, just endless sand stretching to the horizon. Most engineers would call it impossible, but Dubai didn't just build a city in the desert. They built one of the most advanced metropolises on Earth. What you're looking at isn't just impressive architecture, it's a testament to human ambition that required moving mountains of sand, creating artificial coastlines, and solving problems that had never been solved before. The engineering behind every building, every road, every drop of water sounds like science fiction. Today, we're diving into how Dubai transformed from a small fishing village into a global powerhouse through mind-bending mega projects. By the end of this video, you'll never look at sand the same way again. How do you build skyscrapers on sand? Sand shifts, it's unstable, and can't support massive weight. Yet Dubai is home to the Burj Khalifa, the world's tallest building at 828 meters high. The answer lies in extreme foundation engineering. To build the Burj Khalifa, engineers dug 50 meters through sand until they hit solid rock. They created a mat foundation, a massive concrete raft 3.7 meters thick, covering an area larger than 2 football fields. Then they drove 192 concrete piles deep into bedrock, each designed to handle enormous loads. The entire foundation used 58,900 cubic meters of concrete, enough to build a solid wall 3 meters high stretching from New York to Philadelphia. But here's what makes this incredible. Workers had to operate in temperatures exceeding 50 degrees Celsius or 122 degrees Fahrenheit while maintaining millimeter precision. The concrete had to be specially formulated to cure properly in extreme heat. The foundation work required 24-hour construction schedules because stopping concrete pours could create structural weaknesses. Every major Dubai building requires similar extreme foundations. The Dubai Mall sits on a foundation that required moving approximately 1.5 million cubic meters of sand, enough to create a sand dune 300 times the volume of the Statue of Liberty. But foundations are just the beginning. The real challenge was creating infrastructure to support an entire city where none should exist. Dubai gets less than 4 inches of rainfall annually. London gets 23 inches, New York gets 49 inches. Dubai gets almost nothing. So how do you supply water to 3.5 million people in the desert? Through one of the largest desalination operations on the planet. Dubai's network of plants produces 470 million gallons of fresh water daily, enough to fill 712 Olympic swimming pools. The Jebel Ali plant, Dubai's largest, processes 140 million gallons daily, using both multi-stage flash distillation for older units and modern reverse osmosis for newer sections. In MSF, seawater is heated to 120 degrees Celsius, then pressure is suddenly reduced, causing water to flash into steam. This steam condenses into pure water, leaving salt behind. But here's where the engineering gets truly mind-bending. The plant operates 24 hours a day, 365 days a year, and cannot stop. A single day without water production would create a humanitarian crisis. The facility has backup systems for its backup systems, 6 levels of redundancy to ensure water never stops flowing. The scale is staggering. This plant uses approximately enough energy to power 120,000 homes and produces so much salt that Dubai exports it globally. Dubai now produces over 70,000 tons of salt annually, making it one of the world's largest salt exporters. Dubai also solved another impossible problem, cooling an entire city when temperatures exceed 50 degrees Celsius. The Dubai District cooling system carries chilled water through 200 kilometers of underground pipes, serving major districts like downtown Dubai, Business Bay, and Dubai Marina. This isn't just air conditioning, it's industrial-scale refrigeration. The central plants produce water chilled to 4 degrees Celsius, then pump it through insulated pipes to buildings across the city. This centralized system reduces energy consumption by 50% compared to traditional air conditioning. The pipes must maintain 4-degree water temperature while running through desert sand that can reach 70 degrees Celsius. Engineers solved this by using triple insulated pipes with vacuum chambers, the same technology used in space applications. Dubai's engineers weren't content building on existing land. They created new land entirely, and this is where the engineering becomes absolutely insane. The Palm Jumeirah required moving 94 million cubic meters of sand from the Persian Gulf bottom. That's enough sand to build a 2-meter-high wall stretching from Dubai to London. The project took 5 years and cost $12 billion. But here's what most people don't realize. You can't just use any sand. Desert sand is too fine and round, it won't compact properly. Engineers had to dredge specific types of sand from precise locations on the ocean floor. They used sonar mapping to identify sand deposits with the right grain size and composition. And the sand couldn't just be dumped in the ocean. Engineers used rainbowing, specialized ships spraying sand in precise arcs, with each grain placed using GPS precision to ensure perfect island shape. The dredging ships could position sand within 10 centimeters of the target location, even in rough seas. To protect against ocean currents and erosion, they built a massive breakwater using 7 million tons of rock, requiring quarrying an entire mountain. Each stone was precisely sized and shaped to interlock with its neighbors, creating a barrier that could withstand 4-meter waves and 150 kilometers per hour winds. But Palm Jumeirah was just the beginning. The World Islands project moved 321 million cubic meters of sand to create 300 artificial islands arranged like a world map, adding 232 kilometers of new coastline. The World Islands presented even greater challenges. Each island had to be precisely shaped to represent a specific country, requiring sand placement accurate to within 50 centimeters. Engineers had to install underwater cables for electricity, fiber optic networks for internet, and water pipes connecting to the mainland. Through artificial island construction, Dubai increased its coastline by approximately 520 kilometers. The city originally had just 72 kilometers of natural coast. They added more than 7 times that amount. With limited land, Dubai built impossibly tall. The Burj Khalifa isn't just the world's tallest building, it's a vertical city with 163 floors containing offices, residences, hotels, and restaurants. At 800 meters high, the building faces wind speeds exceeding 150 kilometers per hour. Engineers designed a unique Y-shaped cross-section that confuses wind patterns, preventing pressure buildup that could topple the structure. The building's exterior uses special glass that can flex up to 15 centimeters without breaking. Each window panel is individually tested to withstand wind pressures equivalent to a Category 5 hurricane. The building has over 13,000 individual glass panels, each one custom manufactured for its specific location. The building actually sways up to 1.5 meters at the top on windy days. This is intentional design. The building flexes rather than breaks. The building uses tuned mass dampers, 400-ton weights that move opposite to the building's sway, reducing movement by 40%. Getting people to the 163rd floor requires elevators traveling 18 meters per second, 40 miles per hour straight up. The elevator shafts are so long that cables stretch under their own weight. The highest elevator cables weigh 13 tons each and required special steel alloys to prevent stretching. Dubai has over 400 skyscrapers taller than 150 meters, more than any city except Hong Kong and New York. At construction's peak, Dubai had 25% of all construction cranes worldwide, reshaping its skyline faster than anywhere on Earth. The construction boom was so intense that Dubai was completing 1 skyscraper every month for 5 consecutive years. Building modern city infrastructure in the desert created unprecedented challenges that required completely rethinking how cities work. The Dubai Metro's entire 75-kilometer network is elevated because digging subway tunnels in sand is nearly impossible. But elevated tracks in 50-degree heat created new problems. Steel rails expand so much they needed special expansion joints every few meters. The trains required triple-layer insulation and air conditioning powerful enough to cool interiors to 20 degrees when it's 50 degrees outside. The system consumes approximately enough electricity to power 50,000 homes, ensuring passenger comfort in extreme heat. Each metro station is essentially a giant refrigerator, maintaining 24-degree temperatures while outside temperatures exceed 50 degrees. The stations use glass walls that can withstand thermal stress equivalent to heating one side with a blowtorch while cooling the other with liquid nitrogen. The metro system is completely automated with 99.7% on-time performance, processing over 200,000 passenger journeys daily. Dubai International Airport, built on reclaimed land, handles over 80 million passengers annually. Terminal 3 is the world's largest building by floor space, covering 1.7 million square meters, larger than 200 football fields. The runways, built on sand, required 3-meter deep foundations and specialized concrete to handle Airbus A380s, the world's largest passenger planes. Dubai's power grid generates 9,000 megawatts, enough for 7 million homes. Remarkably, 40% of this electricity powers air conditioning alone. The city consumes more electricity per capita than any other major city. This transformation cost for major projects like the Burj Khalifa, Palm Jumeirah, metro, and airport tally over $50 billion. Though experts estimate the total investment, including utilities and infrastructure, likely exceeds $100 billion. Individual projects tell the staggering story. Burj Khalifa cost $1.5 billion, Palm Jumeirah $12 billion, Dubai Metro $7.6 billion, airport expansion $7.8 billion. But here's what makes Dubai remarkable. This happened in just 30 years. In 1990, Dubai was a trading port with 500,000 people. Today, it's a metropolis of 3.5 million, welcoming 16 million visitors annually. The economic impact is equally staggering. Dubai's construction boom created 2 million jobs and generated over $200 billion in economic activity. The city transformed from a regional trading post into a global financial center, with GDP growing from $10 billion in 1990 to over $100 billion today. At the building boom's height, Dubai added a new skyscraper weekly. Construction workers from over 100 countries created one of history's most diverse construction workforces. Dubai built more in 30 years than most cities build in 300 years, creating a modern metropolis from nothing but sand, ambition, and extreme engineering. Dubai's transformation isn't just about construction, it's proof of what's possible when human ambition meets cutting-edge engineer. From 50-meter deep foundations to desalination plants serving millions to artificial islands adding hundreds of kilometers of coastline, Dubai redefined what's possible in construction. Every drop of water, every breath of cool air, every stable foundation in this city exists because engineers solved problems that seemed impossible. They turned the world's most challenging construction environment into one of humanity's greatest building achievements. But Dubai's story continues. With major projects still under construction, this city keeps pushing the boundaries of what engineering can accomplish. If you found Dubai's incredible engineering fascinating, you'll love exploring more mega builds reshaping our world. Subscribe and hit that notification bell for our next journey into the most ambitious construction projects on Earth. Trust me, there are engineering marvels out there that will absolutely blow your mind. Thanks for watching. I'll see you in the next one.